My name is Qaim Abbas, and I have been serving for the last 10 years with the FFC Fauji Fertilizer Company, which is one of the leading manufacturer of urea production. I've been working for the last 5 years as a lead process engineer at ammonia plant, and currently I'm working as an executive engineer. My expertise have been in various fields that include energy optimization, plant troubleshooting, PHA, and design engineering. In my presentation, today will be discussing a brief introduction of Fauji Fertilizer Company. Some of you might be knowing well about it, but the students, as I came to know that most of the attendees are the students, so I would like to introduce a bit about my company as well. Then I'll be coming to the main content of my presentation, that is carefully selected topic of improvement in natural gas condensate drainage system. This topic was selected so that I was told that most of the engineers would be from second to fourth years. So the intent was to just give an idea how the industry tries to manage its problems with indigenous resource and engineering. So that the idea was to give a simplistic understanding of the engineering being done, so that everybody can understand the procedures, the way we pursue with these modifications. Then it will be followed by a question and answer session that I will be welcoming if any of the students or the honorable faculty members would be there to have question and answer session regarding topic. And then we can have a general discussion with any of the topics that you please about. Starting with the FFC. FFC has been in Pakistan since 1978, and it's growing strong ever since. We are the largest urea manufacturer of Pakistan, and our journey of excellence has been marked with more than 7,000 metric ton per day urea production, with a capacity factor of 123% of our design plant loads. We have a service factor of 97%, which is these stats match our competence as well as excellence in at par with the most of the sophisticated plants in worldwide. FFC has been honored with many international awards with respect to our performance and excellence in the field of operations. Just to give an idea, we are being operated by a corporate office in Rawalpindi. We have 2 plants at Gotmachi, that is near Sadaqabad. This is located in Rahimia Khan district. This is the last district in the southern Punjab. Then from that onwards, plant 3. Plant 3 is located in Mirpur, Mathelo. This is an area in interior Sindh. Then we have plant 4 and 5 in Karachi, that is operated by Fauji Fertilizer bin Qasim. We have a urea and a DAP plant in Karachi. So we are, I can say, all over Pakistan, from Islamabad to Karachi. Other than fertilizer business, FFC also has stakes in other businesses like wind energy as well as foods. So you might have heard something about Fauji Fresh and Foods. So that also is an area in which our company is diversifying, apart from the latest developments like of power generation section. Here I would like to just give an idea how urea production has been our stronghold. We have been growing since the day one. You can see that with the inception of the plant 1 in 1982, which was around 570, we were contributing to 570,000 metric ton per year in country's urea production. Then we had a DBN in 1991. Our production rose, and our contribution to the country also increased once again when we installed plant 2 at Gotmachi site, and then followed by an acquisition of formerly operated by NFC plant in Mathelo, that is now called plant 3, and then we had a DBN of plant 3. So currently you can say we are contributing to 2,004,000 metric tons, you can say annually in urea manufacturing of the country. Coming to the topic which we have selected for today's presentation, is regarding improvement in the natural gas condensate drainage system. Coming to the background of the problem, our site is operating. You might be knowing that the raw material for urea manufacturing is natural gas. We obtain our natural gas from a Mari gas field in Deherki, and it is located some around 49 kilometers from the Gotmachi complex. So that means a lot of extended piping, a lot of pressure drop. Over the period of time, these reserves have been depleting as the Brent has been felt by many of us in Pakistan, that the natural gas pressures and natural gas shortfalls, natural gas outages are being felt all across Pakistan. So is the case with the industry. Natural gas reserves are depleting day by day, and the pressure of the wellheads are declining. So this means that this leads to increase in space velocities in the well lines at the end of Mari, and at the same time in our piping network. Increased space velocities leads to carryover from the wells, and also the oil carryover from the wells. Just to give an idea how these affect carryover system affect the performance of the reservoir. It's a just typical geological diagram of the well. Here you can see that this is the impermeable membrane rock, on which normally we walk on, and the source of this rock, which contains the natural gas and oil are located deep beneath. Owing to the high pressure, these oil or gas reserves migrate towards the highest point owing to the density difference, where the antisaline trap is formed, in which gas or the oil or both are trapped. Here the drilling of the rock is carried out, and the gas or the oil reserves is carried out from here. Once the reservoir depletes, this gas quantity also takes away along with it some oil particles. This is what we call condensate. Here is a bit bigger view of the whole picture, that these water salts, oil, and free gas are being pulled out, or they come out with the pressure as a free-flowing gas. And once the pressure of the well starts declining, it carries over with the oil and water. So this leads to our problem that the oil along with condensate comes in the natural gas lines, and this travels in the form of you can say small layers with the walls of the piping. You can understand that the 49-kilometer pipe length with the 16-inch diameter is a huge volume, in which the gas is flowing, and with increasing space velocities, this quantity of water, once it had been traveling along the wall, but over the period of time, it started building up due to bends in the piping in different areas and locations. Just to give an idea how the slug formation happens in these lines, I just Googled a YouTube video which would just give an idea how these slugs are formed. You can see that water is traveling just well along the surface of the piping. But once a slug is formed, this huge quantity of water travels towards system. Normally the processes are designed to handle a certain quantity of water, which is being carried with the gas, and these are knocked out in knocked out systems. But when the slugs of large quantity, more than the design, are being experienced, this leads to water carryover and water carryover with the gas, which abrupts the plant operation as well as affects the quality of the effluents which we are having. Currently, I will be discussing only the problem which we felt due to these slugs and high carryovers with our condensate effluent system. Owing to the depleting wellhead pressures, FFC had to install a compression system at a location just after Mari. So we are currently operating a compression station, which is mostly comprised of PD compressors, which is currently compressing natural gas from wellhead pressure to our required pressure for the battery limit requirements. These pressures are required to sustain our plant operation and current plant loads. These compressors are also source of some oil which is being used in their packing seals. So any oil that is being used in their packing seals also becomes part of the gas which we had to process or receive at our plant battery limit. Moreover, due to extended piping and to ensure its reliable health and life, Korean inhibitors are being dosed in this system so that the corrosion within these lines can be controlled and can be avoided to get a lasting operational reliability. This saturated moisture content is also linked with ambient changes. You can better understand that once the gas is in heated condition, it can carry more of a liquid in its saturated state. But once the gas is cooled due to any ambient change, you can say between day and night, which can cause a delta of around 10 to 15 degrees centigrade, this saturated moisture content decreases, and the water in colder conditions settles into the piping at the bottom. Also, the road crossings and canals also provide the bends, so these condensate get accumulated on those low points, and once their quantity is significant or the space velocity increases, these condensate travel in the form of slugs. As I already told you that the quantity of natural gas condensate received in natural gas receivers has significantly increased with decrease in wellhead pressures, as already depicted in the previous diagram, that the quantity and the frequency of these condensate increases. So we had been experiencing increase in condensate being received at our battery limit area, that is called area 15. In which the natural gas is received and knockouts any moisture content or the condensate coming from the wellheads. This natural gas condensate, when mixes with other effluents, has caused increase in COD. You might have been familiar with the word or the term chemical oxygen demand. That is the oxygen required to neutralize any chemical present in any effluent or stream. This indicates the amount of you can say effluents or chemicals in the condensate that would require environment to neutralize in case they had been they have not been treated. So with national environmental standards, quality standards, we are bound to maintain this quantity with less than 150 ppm in all cases if we want to dispense it off in the environment. Currently, we are, you can say, the plant has been designed with the standard that we dispense these effluents in the SCARP, that is Salinity Control and Rehabilitation Program, in a marshy area near the Pakistan-Indo border. This condensate, or you can say this water that is within NEQS limits, is used as to develop marshy areas at the border lines to increase our defense and military defense actually. So in any case, coming to the topic again, once the COD increases, we have to shift this to our pressure ponds, so because that quality is not, you can say, acceptable for the NEQS limits. So we carry out frequent sampling in every shift and after every 2 or 3 hours, so that we keep this condensate within our limits with the COD content. Currently, the problem being faced is the natural gas condensate from 15 area is drained into nearby oil receiver. 15 area is, as I told you, that natural gas collection system, which comprises of a knockout. I will be showing the drawing in next or in the forward extended slides, in which you can see that the oil, the gas comes from the well area and gets knocked out in the MS 1501 vessel, and from there the condensate is settled down and it is separated and was being sent to oily sievers. Oily sievers are collected in oil and sand removal basin, which is tagged as S1203, and its sole purpose is to separate out any oil and sand on the basis of their density difference from the normal condensate. Then this oil-free wastewater is fully discharged into STOP through another pit, that is S5201. S5201 is basically a collection pit for the both plants as a complex, and from there water is either sent to EP or SCOP based on their analysis. If this CUD exceeds 150 ppm, the condensate is sent to evaporation ponds, else they are sent on the normal route to SCOP. Due to frequent diversions owing to increase in condensate quantity, we had been experiencing that we had to frequently divert this condensate to evaporation ponds. This was resulting into increased level in evaporation ponds and consequently increased load on the company operational expense to buy more land for the evaporation purpose. So it is not a desirable option to divert this condensate to evaporation pond. Moreover, this also increases the load during winters and rainy seasons when the evaporation rate is slow in the evaporation pond, and the rainy season, which also cause increased levels in the evaporation pond. Therefore, considerable increase in the quantity of natural gas has been observed. Correspondingly, instances of high COD in the plant wastewater, drain, and S5201 has been increased. Just to give an idea, this is the graphical representation. In blue line, it's the condensate that is being collected in the 15 area. You can see that back in January 2017, this condensate was started to increase and kept on increasing by the you can say mid 2018 because of declining wellhead pressures. In green line, you can see the declining wellhead pressures. So it relates that with decreasing natural gas wellhead pressures, the condensate being collected in 15 area is on an increasing trend.